Hi guys, I am Vidya and a warm welcome to all of you to my channel. I would be explaining you how to encrypt a given plain text using Affine Cipher. Affine Cipher is basically a set of encryption and decryption algorithm. A encryption algorithm converts a plain text into ciphertext such that the ciphertext is a meaningless message unreadable by any attacker. So, a encryption algorithm takes the plain text and converts it into ciphertext. The ciphertext is a meaningless message and it cannot be decoded by anyone else on the public communication channel other than the receiver who uses the decryption algorithm to decrypt the ciphertext and recover the plain text. However, to encrypt and decrypt, the encryption and decryption algorithm uses same key. Since we are talking about affine cipher, it makes use of two keys, that is K1 and K2. So the sender who is encrypting the data uses K1 and K2 and he also securely shares it with the receiver. So the receiver also uses the same keys K1 and K2 to decrypt. Now what is the algorithm that is used for encryption by affine cipher? Affine cipher generates the ciphertext using plain text multiplied by key K1 added with K2 and it is done on a mod 26 domain, while the decryption recovers the plain text using ciphertext. So he first subtracts the key K2 and multiplies the modulo multiplicative inverse of key K1 and does it using mod 26 operation. So the ciphertext formula that we are going to use is P into K1 plus K2 mod 26 and the plain text formula that we are going to use is C minus K2 multiplied by K1 inverse mod 26. So with this information, we now move ahead to solve numericals on affine cipher. Let us take this particular numerical. Let us say we have a plain text called secret and we have to encrypt it using the key K1 as 3 and K2 as 7. First and foremost, you should know the formula. So what is the formula for encryption? Encryption generates ciphertext using plain text multiplied by the key K1 added with K2. So first is multiplication operation and then is addition operation. Keep it in mind. You have to first do multiplication and then do addition. While when you decrypt, you have to first do subtraction and then you have to multiply with the modular multiplicative inverse. So please keep this in mind or else your answers will go wrong. So we do P into K1 plus K2 mod 26. Now what is K1 given to us? 3. What is K2 given to us? 7. So this is pretty easy. But what is the plain text given to us? Plain text is the word secret. S-E-C-R-E-T. Now plain text that is given to us is alphabets while the encryption algorithm is using multiplication and addition. So the first step in encryption is you should map each of these letters into numbers, for which we use the mapping table. That is, we map letter A to 0, B to 1, C to 2, D to 3, E to 4 and so on and so forth till we reach Z, which is mapped to 25, so that we can assign each of these letters of the plain text a proper number which can be processed by the encryption algorithm. So let us see the encryption process now. So you make a 3-column table and in the first column you write down your plain text letters that are given, that is S, E, C, R, E and T. Now as I told you, the encryption algorithm is a mathematical computation and hence you have to map each of these letters to its corresponding numbers so that it can be processed by the mathematical formula. For this we will require the mapping table which is shown here on the right. Okay, so we use this mapping table where A is mapped to 0, B is mapped to 1, C is mapped to 2 and so on and so forth till Z is mapped to 25. Now we pick up the proper number from this mapping table and put it in this first column. So what is the number corresponding to S? It is 18. What is the number corresponding to E? It is 4. What is the number corresponding to C? It is 2. What is the number corresponding to R? It is 17. What is the number corresponding to E? It is 4. And what is the number corresponding to T? It is 19. Now I have got the numbers which can be easily processed by this algorithm. So what does this algorithm say? This algorithm says that you can generate ciphertext using the plain text, multiply it with key K1. What is K1? 3. And add it with key K2. What is K2? 7. And you have to do a mod 26 operation. So now let us see how to do this. So the first number that you want to encrypt is 18. So you take 18, multiply by 3. So you focus on this formula given here. So 18 into 3 plus 7. How much do you get? You get 61. And it is 61 mod 26. Now we got 61 mod 26. Now since 61 is a number greater than 26, you have to perform modular arithmetic operation. How do you perform it? When you do A mod B, you get an answer C. What is C? C is the remainder of A divided by B. So we take 61 and we divide it by 26. So 26 into 2 is 52. So the remainder is 9. Therefore 61 mod 26, we got the answer as 9. Okay. So now the next number that you want to encrypt is 4. So you will do 4 into 3 plus 7. So which comes out to be 19 mod 26. Now what is the answer of 19 mod 26? As you can see that the number 19 is less than 26. You need not do modular operation. Modular operation is basically done if the number is larger than 26. We bring it within the range of 0 to 25. Now 19 is already a number which is within the range of 0 to 25. Since this number is already between 0 to 25, we need not do modular arithmetic. The number remains as 19. So even if you do the division of 19 divided by 26, it becomes 26 zeros are 0 and the remainder is 19. Therefore 19 mod 26 is 19. Whenever you are doing A mod B, and if A is positive and A is less than B, then A mod B continues to be A. So keep this in mind. So in this case 19 mod 26, we got it as 19. The next number to be encrypted is 2. So we do 2 into K1, which is 3, plus K2, which is 7. So the addition comes out to be 13 mod 26. As we just saw, 13 mod 26. In 13 mod 26, 13 is a number which is less than 26. So since 13 is less than 26, 13 mod 26 continues to remain as 13. So this answer is 13. The next number which we want to encrypt now is 17. So we do 17 into 3 plus 7. The resultant answer we get is 58 mod 26. Now what is the answer of 58 mod 26? Since 58 is greater than 26, you have to do division. As I told you, A mod B is equal to C, where C is remainder of A divided by B, and you perform it when A is greater than B. So you divide 58 with 26. 26 into 2 is 52 and the remainder of this is 6. So the answer of 58 mod 26, we get it as 6. Now the next number which I want to encrypt is 4. So I do 4 into K1, that is 3, plus K2, that is 7. The resultant of 4 into 3 plus 7 comes out to be 19 mod 26. So by now you know how to do 19 mod 26. So since 19 is less than 26, there is no need of doing modular arithmetic. 19 mod 26 directly is equal to 19. Let us now move on to the next number to be encrypted, which is 19. So I take 19 multiplied by the key K1, which is 3, add key K2, that is 7, and the resultant of 19 into 3 plus 7 is 64 mod 26. Now I have to do 64 mod 26. Now how to do this particular thing? Now since 64 is a number which is larger than 26, you have to divide 64 by 26. So 26 into 2 is 52 and the remainder of this comes out to be 12. So 64 mod 26 is 12. So as you see here, we have got the numbers corresponding to the ciphertext. Okay, so the algorithm has generated the numbers, but we want to recover the letters now from the numbers and make a word from it. So the plain text given was the word word secret. Corresponding to the word secret, we have to find what is the word for ciphertext. So now the next step is to map each of these numbers to its letters. So how do we map these numbers to letters? By using the mapping table. So we'll use this table which is shown at the right and reconstruct our letters from these numbers. So as you can see from the table, 9 corresponds to J. Number 19 is assigned to letter T. Number 13 is assigned to letter N. Number 6 is assigned to letter G. Number 19 is assigned to letter T. Number 12 is assigned to letter M. So these are the ciphertext letters we got from the mapping table. Therefore, for plain text which was given as word secret, using the key 3 and K2 and using the encryption algorithm of affine cipher, we recovered the ciphertext which is JTNGTM. So the final answer of ciphertext is the following word, JTNGTM. So this is how encryption using affine cipher is done. So thank you guys. Stay healthy, stay happy, stay blessed. See you in my next video.